Okay. Give me one quick second. Um, Make sure the sound is good. Okay, perfect. So we're not gonna make the mistake and put the music so that YouTube can knock it down. We have to wait 2 minutes so there'll be no cursing. So let's continue with the Honda NSX first generation. So picking up official test time in 2 minutes. Go ahead and hydrate. Everybody get comfortable, get your snacks. It is a chill zone, but you guys still have finals, even though you guys are graduating. We are going to go rapid fire pace, okay? And we're going to finish the entire exam. So you guys should be ready. You have a minute and change. Um, what do I think I'm gonna need? I'm gonna wait to see as we develop to see if we need to add more things into the simulator. Um, Honda NSX first generation is the beginning of chapter 2, almost at the 2 minute mark. 2 minute and change, we will start chapter 2. This article is about the first generation of the Honda NSX produced between 1990 and 2005. For the model reintroduced in 2016, see Honda NSX second generation. Guys, have a few more seconds. Let's hydrate. Make sure we drink lots of water during testing. Sometimes you cannot get up to use the bathroom. You got to finish your exam because you're being timed and, you know, not really allowed to eat when you're taking an exam. So, sometimes you have to try to have at least, something really cold to drink. Give me one quick second. We'll let that cool down a little bit. All right. Are we ready? Yep. Official start time. Um, 247. Okay. Okay. Honda NSX first generation. The first generation Honda NSX, new sports car experimental, marketed in North America and Hong Kong as the Acura NSX, is a two-seater mid-engine sports car that was manufactured by Honda in Japan from 1990 until 2005. Development. Around 1984, Honda engineers began experimenting with different engine and chassis layouts to test viability for future products. One of the test mules was a Honda City that had been cut in half, with the engine installed behind the driver's seat and powering the rear wheels. Although the project was not developed any further, many of the engineers were inspired by the exciting laps around the company parking lot in the mid-engine city. This experience in part convinced Honda leadership that the company should consider developing a pure sports car. As a result, in 1984, Honda commissioned the Italian car styling house Pininfarina to design the concept car HPX, Honda Pininfarina Experimental, which had a C20A 2.0-liter V6 engine in a mid-mounted configuration. After Honda committed to a sports car project, the company management informed the engineers working on the project that the new car would have to be as fast as anything coming from Italy and Germany. The HPX concept car evolved into a prototype known as NSX, which stood for New Sports Car Experimental. The prototype and eventual production model, which was marketed as the NSX, were designed by a team led by Honda chief designer Masahito Nakano and executive chief engineer Shigeru Uehara, who were subsequently placed in charge of the S2000 project. I got to work with the Uehara family. Um, we have some very, very nice MR2s. The original performance target for Honda's new sports car was the Ferrari 328 and later the 348. As the design near completion, Honda intended its sports car to meet or exceed the performance of the Ferrari while offering superior reliability and a lower price. For this reason, the 2.0-liter V6 engine utilized in the HPX was shelved and ultimately replaced with a significantly more powerful 3.0-liter VTEC V6 engine. Over the course of development of the NSX, many engines were used, ranging from the 2.7-liter single overhead camshaft V6 engine from the Honda Legend Honda Coupe to the 3.0-liter single overhead camshaft V6 engine, which we know as the J series, used subsequently in 15 test mules. Honda eventually settled on a non-VTEC 3.0-liter double overhead camshaft 24-valve V6 engine selected for the production model. They wanted it to have a naturally aspirated feel. They knew they could deliver a V8 high performance with a V6. That's what it was. They were challenging them. This engine generated a maximum power output of about 250 horsepower, 186 kilowatts, or 253 PS, and 282 newton meters, 208 pound-feet of torque, with a red line of 7,300 RPM. However, at the same time, Honda was working on its revolutionary VTEC variable valve timing system, with plans to release it on the company's home market four-cylinder Integra. Honda's then president, Tadashi Kume himself, a highly skilled and respected engine designer, questioned the NSX designer's logic in foregoing the VTEC system for Honda's new flagship sports car while it was being used on the lower market Integra. As a result, the engine was redesigned very late in the development process to achieve the desired levels of performance and durability. Honda designed a new cylinder block with 6-bolt main caps and larger cylinder heads to contain the complex VTEC mechanism. Innovative connecting rods made from a titanium alloy were used to lower reciprocating weight while increasing overall rod length, something which increased the engine's maximum RPM by 700, resulting in a final red line of 8,000 RPM. A consequence of this last minute engine change was that the new C30A engine was too large to fit in the NSX's engine bay, which had been carefully seized for the smaller heads of the non-VTEC dual overhead cam 3-liter engine. As a result, the engineers were forced to tilt the entire engine backward approximately 5 degrees, a characteristic that continued all the way to the NSX final production in 2005. The exterior design had been specifically researched by Uehara after studying the 360-degree visibility inside an F-16 fighter jet's cockpit. Thematically, the F-16 came into play in the exterior design as well as establishing the conceptual goal of the NSX. In the F-16, another high-performance aircraft such as unlimited hydroplanes, along with open wheel race cars. The cockpit is located far forward in front of the power plant. This cab forward layout was chosen to optimize visibility, while the long tail design enhanced high speed directional stability. Come on, B. This is the F-22, yo. This is the baby F-40. That's what it was always intended to be. The NSX was designed to showcase several automotive technologies, many derived from Honda's Formula One motorsports program. The NSX was the first production car to feature an all aluminum semi monocoque, incorporating a revolutionary extruded aluminum alloy frame and suspension components. The use of aluminum saved nearly 200 kilograms, 441 pound-feet of weight over the use of steel in the body alone, while the aluminum suspension arms saved an additional 20 kilograms, 44 pounds. A suspension compliance pivot helped maintain wheel alignment changes at a near zero value throughout the suspension cycle. Other notable features included an independent 4-channel anti-lock brake system, an electric power steering system, Honda's proprietary VTEC variable valve timing system, and in 1995, the first electronic throttle control fitted in a Honda production car. With a robust motorsports division, Honda has significant development resources at its disposal and made extensive use of them. Respected Japanese Formula One driver Satoru Nakajima, for example, was involved with Honda in the NSX's early on track development at Suzuka Race Circuit, where he performed many endurance distance duties related to chassis tuning. Brazilian Formula One world champion Ayrton Senna, who won many races in Formula One with Honda powered McLarens before his death in 1994, was considered Honda's main innovator in convincing the company to stiffen the NSX's chassis. Further, after initially testing the car at Honda Suzuka GP circuit in Japan, so that means the whole NSX was designed for that track. Senna further helped refine the original NSX's suspension, tuning, and handling by spending a whole day test driving prototypes and reporting his findings to Honda engineers after each of the day's 5 testing sessions. So they tested it 5 times a day. Senna also tested the NSX at the Nürburgring. So this car is the perfect balance to drive perfectly at the Suzuka race circuit and the Nürburgring. That's why it's the perfect balance. Senna also tested the NSX at the Nürburgring and other racetracks. As a result of Senna's input, Honda took the NSX prototype to the Nürburgring to tune the chassis stiffness. So it needed to go to the Nürburgring so that they can make the chassis perfect. They didn't even care about the Nürburgring. Whatever records they broke was for free because they really wanted to break the records at Suzuka. That makes perfect sense. Asia makes the best cars because they have the best roads. As a result of Senna's input, Honda took the NSX prototype to the Nürburgring to tune the chassis stiffness over the course of several months, 5 times a day over several months. The chassis was refined in a painstaking process. Nakajima would drive a lap on the circuit and then discuss with Honda engineers where he felt flex in the chassis. The engineers would hand weld aluminum braces in the area they believed would fix the issue and send the driver back out to confirm. This process was repeated over and over, with the data results sent directly to Honda headquarters in Japan, where it was fed into a crate supercomputer and translated into reinforcements in the production aluminum monocoque. As a result of this process, the NSX chassis stiffness increased by over 50% with only a small increase in weight. The suspension development program was similarly far ranging and took place at the Toshigi Proving Grounds, the Suzuka Circuit, the 179 turn Nürburgring course in Germany, HPCC, and Honda's newest test track in Takasu, Hokkaido. Honda automobile dealer Bobby Rahal, 1986, Indianapolis 500 champion, also participated in the development and testing of the suspension. So you have three of the world's greatest drivers coming together to fine tune this amazing chassis. One second. Okay. Official launch and production. The NSX made its first public appearances in 1989 at the Chicago Auto Show in February and at the Tokyo Motor Show in October of that year, receiving positive reviews. Honda revised the car's name from NSX to NSX before commencement of production and sales. The NSX went on sale in Japan in 1990 at Honda Verno dealerships sales channels, supplanting the Prelude as the flagship model. The Prelude is a baby NSX as well, especially the SIRs. So if you could get your hands on a right-hand drive JDM, that's a baby NSX and four-wheel steering. The NSX was sold under Honda Acura's luxury brand starting in November 1990 in North America and Hong Kong. Upon its official debut, the NSX design concept showcased Honda's technology, measuring only 1,170 millimeters, 46 inches in height. The Japanese car maker's racetrack innovations and competitive history were further exemplified on the road by the NSX's ultra rigid and ultra light all aluminum monocoque chassis, along with front and rear double wishbone suspension with forged control arms connected to forged alloy wheels. The car additionally boasted the world's first production car engine with titanium connecting rods, forged pistons, and ultra high revving capabilities. The red line was at 8,300 RPM, all traits usually associated with track and race engineered cars. The NSX's exterior had a dedicated 23-step paint process, including an aircraft type chromate coating designed for chemically protecting the aluminum bodywork, and a waterborne paint for the base coat to achieve a clearer, more vivid top color and a smoother surface finish. The car's chassis rigidity and cornering handling capabilities were the result of Formula One driver Ayrton Senna's consultation with NSX chief engineers while testing the NSX prototype at Honda's Suzuka circuit during its final development. The NSX was initially assembled at the purpose-built Takanezawa R&D plant in Toshigi from 1989 to early 2004 when it was moved to Suzuka plant for the remainder of its production line. The cars were assembled by approximately 200 of Honda's highest skilled and most experienced personnel, a team of hand-picked staff with a minimum of 10 years assembly experience employed from various other Honda facilities to run the NSX operation. So they're telling you the formula right here. You need around 200 people to build one NSX. And these are people that at a bare minimum have 10 years engineering experience in whatever their specialty is. So imagine that's just the entry level. Imagine what your top engineers experiences can be. Production of the first generation of the NSX ended on November 30th, 2005. Sales in the United States and Canada ended in 2005 and 2000, respectively. As the end of June 2005, the NSX achieved total worldwide sales of more than 18,000 units in over 15 years. So this is a good run. They made a little over 1,000 cars um, a year for 15 years. That's a very good run. Okay, now let's continue with variants because this is what's going to lead to NSX GT and then to HSV and then the prototypes and then the second generation. But we still need to compare this to F80 and all the vehicles in between. NSXR variants, 1992. While the NSX always was intended to be a world class sports car, engineers had made some compromises in order to strike a suitable balance between raw performance and daily drivability. For those NSX customers seeking a no compromise racing experience, Honda decided in 1992 to produce a version of the NSX specifically modified for superior track performance at the expense of customary creature comforts. Thus, the NSX Type R, or NSX-R, was born, the Green Ranger baby. Honda chose to use its moniker of Type R to designate the NSX-R race-orientated capabilities. Honda engineers started with the base NSX Coupe and embarked on an aggressive program of weight reduction, sound deadening the audio system, spare tire, air conditioning system, and traction control, along with some of the electrical equipment were removed. However, these could be available as options. The power leather seats were replaced with lightweight carbon Kevlar racing seats made by Recaro for Honda. However, electric windows and fore-aft electric seat adjusters were retained. The stock forged alloy wheels were replaced with lighter forged aluminum wheels produced by Enkai, which reduced the car's unsprung weight. The standard leather shift knob was replaced with a sculpted titanium piece. Overall, Honda managed to reduce approximately 120 kilograms, 265 pounds minus options of weight as compared to the standard NSX, resulting in the NSX-R final weight of 1,230 kilograms, 2,712 pounds. As found by the automotive press, such as Car and Driver, in their September 1997 issues comparison of best handling car for more than $30,000, the NSX, due to its mid-engine layout and rear-end link travel, was susceptible to a sudden oversteer condition during certain cornering maneuvers. While this condition rarely occurred during normal driving conditions, it was much more prevalent on racetracks where speeds were much higher. To address the problem and improve the NSX-R cornering stability at the limit, Honda added one aluminum bracket under the front battery tray and added one bracket in front of the front radiator to add more chassis rigidity, replacing the entire suspension system with a more track-orientated unit featuring a stiffer front sway bar, stiffer suspension bushings, stiffer coil springs, and stiffer dampers. The standard NSX has a somewhat rearward bias in its spring and bar rates. where the rear was relatively quite stiff versus the front. This means that the lateral load transfer distribution, or the amount of load that is transferred across the front axle versus the rear while cornering, is rather rear biased. This can make the car quite lively and easy to rotate at low speed, but during high speed cornering, this effect becomes more pronounced and could be a handful to manage. To reduce the tendency to oversteer, Honda fitted softer rear tires on the NSX. For the NSXR, Honda reversed the spring bias, placing stiffer springs on the front suspension along with stiffer front sway bars. This shifted the load transfer stiffness balance farther forward, resulting in more rear grip at the expense of front grip. This had the effect of decreasing the oversteer tendency of the car, making it much more stable while cornering at high speeds. Overall, the NSXR utilizes a much stiffer front sway bar along with stiffer springs than the standard NSX, 21 millimeters, 2.6 millimeters front sway bar, front 3.0 kilogram millimeter, rear 4.0 kilogram millimeter for the NSX versus front 8.0 kilogram millimeter, rear 5.7 kilogram millimeter for the NSXR. Honda has also increased the final drive ratio to a 4.235 to 1 in place of the 4 to 6 to 1, which resulted in faster gear changes. This change improved acceleration, which was 4.9 seconds to 60 miles per hour, at the expense of top speed, which was 168 miles per hour, and a higher locking limited slip differential was installed. Also, the NSX-R's 3-liter engine had a blueprinted and balanced crankshaft assembly, which is exactly the same labor-intensive, high-precision process done for Honda racing car engines, built by highly qualified engine technicians. So top speed is 168. Let's go very quickly to 328 so that we can remember what is the top speed. Let's see if you guys remember this is on your exams. Okay, production. Let's go to performance. Pass the engine, pass chassis. Performance. 0 to 60, 5.5 seconds. Let's go back to the NSX. So it's okay. NSX is 0 to 60 in 4.9 seconds. The 328 is 5.5, so it's 0.6 seconds faster. Top speed for the 328 GTS, 166 miles per hour for the GTB. Top speed on the NSX, 168. It beat it by 2 miles per hour. Engine 3-liter, the same. Let's continue. Beginning in late November 1992, Honda produced a limited number of 483 NSX-R variants exclusively for the Japanese domestic JDM market. Factory optional equipment such as air conditioning, Bose stereo system, carbon fiber interior trim on the center console, as well as the doors, and larger wheels painted in championship white, 16 inches at the front and 17 inches at the rear, were available for a hefty premium. Production of the NSX-R ended in September 1995. So basically, look what they offered in only less than 500 vehicles, and the car is legendary. It did everything it was designed to do. They made a ton of money off that car. They made at least 8,000% on their investment. Okay, NSX Targa. 1995. Beginning in 1995, the NSX Targa, with a removable Targa top in black color, was introduced in Japan as a special order option and in North America in March 1995. The NSX-T largely replaced the standard coupe entirely in North America as the only version available post 1994, and all NSXs thereafter were available in Targa body style, with two notable exceptions: the Zanardi Special Edition NSX in 1999 and a handful of special post 1997 pre 2002 3.2-liter base model cars, both of which retain the original hardtop configuration. The European market continued to offer both body styles. The removable roof resulted in decreased chassis rigidity, and Honda added about 100 pounds, 45 kilograms, of structural reinforcements to compensate, including significantly thicker frame side sill rocker panels. The body component, which contributes most to the chassis rigidity, bulkheads, roof pillars, and the addition of new front rear bulkhead and floor plan cross members. The Targa models manufactured for the rest of the NSX production run through 2005 sacrificed weight and some of the original coupe's chassis rigidity, rigidity in return for an open cockpit driving experience. In addition to this major change, all subsequent NSXTs 1995 through 2001 had a smaller diameter, front sway bars, slightly stiffer front springs, softer rear springs, and firmer shock dampers to improve ride comfort and tire wear while reducing the tendency towards oversteer common in mid-engine vehicles. The small handful of special ordered base model hardtop NSXs from 1997 to 2001 still retain the original black roof. All other roofs post 1995 were now body colored instead of black, although in Japan, the two-tone black roof body color was still available as an optional feature. A lighter version of the variable ratio electric assisted power steering rack, previously found exclusively in the cars equipped with the automatic transmission, became standard on all models. Starting in 1995, the 5-speed transmission's second gear ratio was lowered by 4.2% to improve drivability and provide better response, and automatic transmissions received an optional Formula One inspired sports shift with a unique steering column mounted electronic shifter. Manual transmission cars received an improved torque reactive limited slip differential when combined with a new throttle by wire system, increased corner exit speeds by 10%. Other innovations beginning in 1995 included a new and lighter exhaust system and muffler configuration for greater efficiency and lower emissions, an OBD2 onboard diagnostic system, improvements in the traction control system (TCS), and newly developed fuel injectors. 1997 Performance Upgrades. In 1997, Honda introduced the NSX's biggest performance upgrade for all of its worldwide markets. Engine displacement was increased from 3.0 liters to 3.2 liters using a thinner, fiber reinforced metal (FRM) cylinder liner. The exhaust manifold was reconfigured and made of stainless steel header pipes rather than a cast iron manifold for improved performance and lighter weight. The increased flow from this new configuration was a key contributor to the 20 additional horsepower drawn from the new engine. This revised 3.2-liter C32B engine provided a substantial increase to power output from 274 PS, 202 kilowatts, or 270 horsepower to 294 PS, 216 kilowatts, and 290 horsepower, while torque increased from 285 newton meters, 210 pound-feet of torque, to 305 newton meters, 225 pound-feet of torque for cars equipped with manual transmission only. The net result increased the power to weight ratio of the NSX by 7%. The 4-speed automatic model retained its 3.0-liter engine and 252 horsepower output. Another big change was the adoption of a 6-speed manual transmission with closer gear ratios and the addition of third to fourth gear dual cone synchronizers to handle the new engine's added torque and power. The small diameter twin disc clutch system and the 5-speed was replaced by a dual mass low inertia single disc clutch system to offset the weight increase of the new 6-speed transmission and the larger brake rotors, which had increased diameter from 282 millimeters, 11.1 inches, to 298 millimeters, 11.7 inches. Key body parts were made with a new aluminum alloy that was up to 50% stronger, allowing the thinner, lighter material to be used in the doors, fenders, and front and rear deck lids without any sacrifice of strength and rigidity. Using this high-strength alloy, the net curb weight increase, despite adding many improvements, was only 10 kilograms, 22 pounds. Other notable changes included a keyless entry system, vehicle immobilizer system, and inclusion of electric power steering on the hardtop coupe trims. The combination of slightly increased power and torque and a new 6-speed transmission with ratios optimized to improve straight line acceleration produced better performance numbers over previous models than the modest increases would suggest. Motor Trend and Road and Track's February 97, 1997 issue test the 3.2-liter 6-speed equipped NSX Targa resulted in a 0 to 60 mile per hour acceleration times of 4.8 and 5.0 seconds, and a quarter mile times of 13.3 and 13.5 seconds, respectively. 0 to 60 times dropped to as low as 4.5 seconds in the 3.2-liter coupe variant, as recorded by Car and Driver in their August 1990 0 to 150 back to zero issue. The NSX proved to be the fastest ever tested in North America when tested by the magazine. When Car and Driver tested the 1999 Zanardi Special Edition Coupe a year later, it resulted in a 0 to 60 mile per hour acceleration time of 4.8 seconds and a 13.2-second quarter mile time. Magazine tests for the later facelift NSX are more rare than when originally introduced. 1997 NSX Type S, along with the engine displacement increase. In 1996, Japan exclusively received the NSX Type S. The Type S was intended to be a winding road optimized trim option, and incorporated several weight-reducing features to improve performance. Titanium shift knob, Momo Zagato style steering wheel, BBS lightweight aluminum wheels, 16 inches by 17, and a lightweight rear spoiler. The NSX also carried over several weight-reducing features from the earlier NSX-R: Recaro full bucket carbon Kevlar, Alcantara leather seats, mesh design engine cover, single pane rear glass, manual rack and pinion steering, and a lightweight battery. Unlike the NSX-R, which used the black roof from the original NSX, the Type S was offered with a white with a body color matching roof. Overall, the weight reduction efforts resulted in a curb weight of 1,320 kilograms, 2,910 pounds for the Type S, which was some 45 kilograms, 99 pounds lighter than the standard NSX coupe. However, due to its premium trim level, customers could add options like navigation, electric power steering, HID xenon headlights, and fog lights, partially negating some of the weight savings. Indeed, the NSX Type S was the most expensive NSX trim model available in 1997 at 10,357,000 yen, or 85,000 in 1997 dollars. Honda also extensively revised the Type S suspension to incorporate much stiffer front dampers and a thicker rear sway bar. Honda produced 209 NSX Type S units between 1997 and 2001. Again, less than 485 Type Rs, 209 Type S's. Now listen to this, JDM only, baby. 1997 Type S Zero. Along with the Type S, Honda offered the NSX S Type Zero for customers who desired a track day weekend car and who would normally purchase the now discontinued NSX-R. So this is really the second gen NSX-R, 97. Design designated Zero to indicate extreme weight reduction. The S0 is a more circuit-oriented version of the standard Type S. Handling was improved for the circuit by using NA1 NSX-R suspension, but retaining the Type S thicker 19.1 millimeter rear sway bar. The S0 also ditched the dual mass flywheel clutch and reverted to the lighter, more direct dual clutch from the original NSX 5-speed transmission. They made a mistake. They knew that first transmission was the best one. Unlike the standard Type S, the S0 did not offer cruise control, stereo, power door locks, airbags, traction control, power steering, fog lights, or a navigation system. Air conditioning, however, was the only option. Much of the sound deadening material was also removed to reduce weight. All of this weight reduction resulted in making the S0 50 kilograms, 110 pounds lighter than the Type S, weighing in at 1,270 kilograms, 2,800 pounds even. Combining extreme weight reduction with the power and performance improvements of the new 2.0, no, 2.3, 3.2 liter engine and 6-speed manual transmission. The F-Zero could lap the Suzuka circuit 1.5 seconds faster than the already formidable NSX-R. Only 30 NSX Type S Zeros were produced between 1997 and 2001, making it the rarest version of the NSX next to 5 homologation special NSX-R GT cars. Unbelievable, man. Unbelievable. It's like just learning about a vehicle like this, you're willing to pay millions of dollars for it because you appreciate how much goes into the engineering, how rare they really are, how special they are. You know, it was like the dream of some young engineers that came true. You know what I'm saying? Like that's inspirational, man. And I hope that that's what you guys are drawing from it as well. Give me one quick second. Let me organize myself right here so we can continue. Let me make sure. Okay. All right. Let us continue. Let me see if I can get a little bit better adjusted here. Okay. All right. So now let's make sure. Okay, we're good right here. Perfect. All right. So let's continue now. 1999, Alex Zanardi edition for the United States of America. Produced exclusively for the United States, the NSX Alex Zanardi edition was introduced in 1999 to commemorate Alex Zanardi's two back-to-back kart and IndyCar championship wins for Honda in 1997. Give me one second. And 1998. Only 51 examples were built, and they were available only in Formula Red to reflect the color of the winning Zanardi. I'm sorry, let's bring that back. Only 51 examples were built, and they were available only in Formula Red to reflect the color of the winning car Zanardi drove for Chip Ganassi Racing. The Zanardi edition was similar to the Japanese market NSX Type S. Visible differences between the Zanardi edition and the Type S were the Zanardi's left-hand drive configuration, black leather and suede seats with red stitching, airbag-equipped Acura steering wheel, and a brushed aluminum plaque with an engraved Acura logo, Zanardi's signature, and a serial number on the rear bulkhead. Total vehicle weight was reduced by 149 pounds, 68 kilograms, as compared to the NSX Targa, through the use of a fixed roof, lighter rear spoiler, single pane rear glass, lightweight BBS alloy wheels, a lighter battery, and a manual rack and pinion steering system in place of the electric power steering. Zanardi Number Zero was a press car that also appeared in auto shows across the country. In a handling test in Rolling Track's June 1999 issue, the Zanardi NSX placed second against the Dodge Viper GTS R. Just imagine how much power the GTS R has. It placed second place against the GTS R. We should place that as a contender. We definitely, all right. Here comes a new challenger. Viper GTSR Wiki. Let's put that on the simulator. I got to see the specs on this. And we're going to see how this is a race car, yo. We got to see how this fares up in the dimensions. So let's go with length 179. What do we have here? 184, 179.7 for the 296 Ferrari, 177 9, no, 178.5. So let's go 179 1. Let's put this on the simulator. Hold on, because that's incredible right there. 178.5, 179 1. Let's see. 179 7, 179 1. So it is right, 178.5 and 179 1. And then we're going to 179.7. So it's right above 992, the new Porsche. Then it's the Viper, and then it's 296 GTB, the new shit. Okay, so let's continue. Zanardi number 0 was a press car. Oh, wait a minute. Before we even do that, let's find out how powerful that shit is. Because I know that that shit is ridiculously powerful. And category, engine. Come on, tell me the power. What kind of engine? Naturally aspirated. Okay. Naming, GTS, racing history. No, we need powertrain. We need the figures. Overall years. Nope. Replacement. No, 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 no. What's power in this thing? Development, racing, Team Orica, 96 to '05. And they're talking about what year is this? 99. So 99. We need the 99 model. Hold up. 91. 24 hours of Le Mans. 787B was 89. I know that for sure. Modifications. Life for the V10. Concentration. What's the engine code? It's not telling me. Okay, hold up. It'd be easier to do it through the engine code, but it's not showing me horsepower figures. Main article, championship edition. Nope, not that one. This is incomplete specs. We're gonna have to Google this. Transmission, Tramic, power. Okay, 600 to 770 horsepower. You telling me a car with a third of the power from the lowest 600 and a fourth of the highest is second place? What is the weight of this car? Give me the weight of this car. What is the weight of this car? Wheelbase, track. It's not giving me nothing. Okay, perfect. What is the length? 179.1. All right, back to the NSX. Zanardi number 0 was a press car that also appeared in auto shows across the country. In a handling test in Road and Track's June 1999 issue, the Zanardi NSX placed second against the Dodge Viper GTS R, Lotus Esprit, Porsche 911 Carrera 4, Ferrari F355 Spider, and Chevrolet Corvette C5 Coupe. The car was also featured in Car and Driver's July 1999 issue before being sold to a private individual. Zanardi number 1 belongs to Zanardi himself and was not given a North American VIN. The car is rumored to have been modified by Honda with hand-activated throttle, braking, and shifting mechanisms to accommodate Zanardi's loss of both legs, resulting from his lounging Lautzy Sitzring crash in 2001. Sonardi numbers 2 through 50 were sold through the general public through dealers. 2002 facelift. In December 2001, the NSX received a facelift in order to keep the car more modern looking, while its competitors, the original pop up headlamps, were replaced with fixed xenon HID headlamp units, along with slightly wider rear tires to complement a revised suspension. The gauge faces changed to a blue shade, and in 2004, the shift knob was changed to a weighed metal ball from the prior leather wrapped plastic. Front steering front spring rates were increased from 3.2 kilograms to 3.5 kilograms. Rear spring rates were increased from 3.8 kilograms to 4.0 kilograms, and the diameter of the rear stabilizer bar increased from 17.5 millimeters to 19.1 millimeters with a 2.3 millimeter wall thickness. The tail light housings were also revised along with the rear spoiler, which now included a small flap on the deck lid. The rear valance was lowered and wrapped around the car to revise side skirts. These changes made the car appear to sit lower on the ground. Due to the changes in design, the drag coefficient slightly dropped to 0.30, which contributed to improvement in acceleration and top speed, with an improvement in the 0 to 201 kilometer per hour or 0 to 125 mile per hour acceleration time by zero point 0.2 seconds, and an increased top speed of 282 kilometers per hour or 175 miles per hour, which is 7 miles per hour faster. So you already knew the formula. If you continue to adjust the power, you could pass 200 miles an hour. So you divide the horsepower available by the gearing, by the top speed, and that's going to give you 175 units. Then you calculate what you need to go over 200, which that car is very well capable of doing about 209 miles an hour with enough power. The hardtop coupe was no longer available in North America from 2002 onwards, but coupes could still be ordered in Japan. The NSX Type S also received the same cosmetic updates with a slight revision to the suspension, replacing the linear rate springs with progressive springs. The S0 trim model was canceled due to the reintroduction of the NSX-R. The NSX was now made available in a number of exterior colors with either a matching or black interior to provide a number of possible color combinations. A 4-speed automatic transmission with manual type shift option also became available. NSX-R Facelift 2002. A second iteration of the NSX-R was unveiled in 2002, again exclusively in Japan. As with the first NSX-R, weight reduction was the primary focus for performance enhancement. The NSX-R was again based on the coupe due to its lighter weight and more rigid construction. Carbon fiber was used to a large extent throughout the body components to reduce weight, including a larger and more aggressive rear spoiler, vented hood, and deck lid. The vented hood was said to be the largest one piece carbon fiber hood used on a production road car. Additionally, the original NSXR weight reduction techniques were repeated, including deletion of the audio system, sound insulation, and air conditioning. Furthermore, the power steering was removed. A single pane rear divider was again used, as were Recaro carbon Kevlar racing seats. Finally, larger yet lighter wheels resulted in a total weight reduction of almost 100 kilograms. Give me one quick second. Let me make sure I adjust myself. Okay, almost dropped this thing right here. Okay, sorry about that. Okay, okay. Um, okay, the NSXR, the original NSXR weight reduction techniques were repeated, including deletion of the audio system, sound insulation, and air conditioning. Furthermore, the power steering was removed. A single pane rear divider was again used, as were Recaro carbon Kevlar racing seats. Finally, larger yet lighter wheels resulted in a total weight reduction of almost 100 kilograms, 220 pounds, to 1,270 kilograms, 2,800 pounds. The 3.2-liter dual overhead cam V6 engines received special attention as well. Each car's engine has or was hand assembled by a skilled technician using techniques normally reserved for racing programs. Components of the rotating assembly, pistons, rods, and crankshaft were precision weighed and matched so that all components fell within a very small tolerance of weight differential. Then the entire rotating assembly was balanced to a level of accuracy 10 times than that of a typical NSX engine. This balancing and blueprinting process significantly reduced parasitic loss of power due to inertial imbalance, resulting in a more powerful free revving power plant with an excellent throttle response. Officially, Honda maintains that the power output of the NSX-R engine is rated at 290 horsepower, 220 kilowatts, which is identical to the standard NSX. The automotive press, however, has long speculated that the true output of the engine is higher, creating the impression of increased power. The accelerator was retuned, becoming much more sensitive to movement, particularly at the beginning of the pedal's new shorter stroke. This, coupled with the harsh suspension, makes it difficult for the driver to drive smoothly at low speeds on streets with even slight bumps. The lack of power steering has also been noted by drivers as making the car tiring and hard to steer at low speed. The result of Honda's second NSX-R effort was a vehicle that could challenge the latest sports car models on the track despite having a base design that was more than 15 years old. For example, noted Japanese race and test driver Motoharu Kurosawa piloted a 2002 NSXR around the Nürburgring road course in 7 minutes 56 seconds at a time equal to a Ferrari 360 Challenge Stradale. We're talking a car that was over 400 horsepower. The NSXR accomplished this feat despite being outpowered by the Ferrari by over 100 brake horsepower. NSXR GT 2005. Production of the NSXR GT as limited edition of NSXR was approved at Honda solely to win at the JGTC and Super GT because its production-based race car homologation required additional handicap weight for NSX by reasoning by such as relatively small aero projected area and midship layout, and overcoming the handicap was very difficult in 2003 and 2004 seasons, as the Super GT rule required at least 5 production cars for any race car version to compete. The production of NSX-R GT was limited to the minimum number, and only one car was actually sold. One clear difference between the second generation NSX-R is the addition of a non-functional garnish snorkel attached to the rear window of the car. In the JGTC NSX race cars, however, this snorkel is fully functional, feeding outside air to an individual throttle body intake system plenum. The NSX RGT also has 180 millimeter longer and 90 millimeter wider body with aggressive aerodynamic components such as an extended front splitter lip and large rear diffuser were used as well. It was also speculated that the NSX-R GT incorporates more weight savings over the NSX-R. It has the same 3.2-liter dual overhead cam V6 engine. Motorsports 24 Hour of Le Mans. The NSX GT1 and GT2 Le Mans race cars started out as factory NSX-R shells. 11 of these shells were shipped to TC Prototypes in England, where they were extensively reworked in preparation for race duty. A custom dry carbon fiber tub was bonded to the exterior, and additional dry carbon fiber pieces were used to reinforce the already stiff chassis. The suspension was completely replaced by a custom setup with raised dampeners and aluminum control arms made to center nut-style wheel hubs. TC added wide-body fenders to accommodate the wider race tires and improved downforce. The C38 engine was extensively revised to include a dry sump oiling system, larger cams, Inconel exhaust headers, and, for the GT2 cars, a massive carbon fiber intake plenum with 6 individual throttle bodies. The GT1 engines received a turbocharger with a custom dual plenum aluminum manifold using bespoke engine management. The GT2 engines produced nearly 400 brake horsepower, a 130 brake horsepower increase from the production version, and the turbocharged GT1 engines produced over 600 brake horsepower, making them the most powerful engines Honda ever used in the NSX. Both engines were mated to a Hewland 6-speed sequential transmission, the use of which would later plague the cars in the Le Mans race. The NSX made 3 appearances at the 24 Hours of Le Mans in 1994, 1995, and 1996. 3 Honda NSXs were entered in the 1994 24 Hours of Le Mans. Cars number 46, 47, and 48 were prepared and run by Team Kremer Racing Honda, with Team Kunimitsu assisting in driving the number 47 car. All were in the GT2 class, and all completed the race but placed 14th, 16th, and 18th. Three Honda NSXs were entered in the 1995 24 Hours of Le Mans. Honda's factory team brought two NSXs, which were entered in the GT1 class, numbered 46, naturally aspirated, and 47, turbocharged. Team Kunimitsu Honda prepared and entered a naturally aspirated NSX into the GT2 class, numbered 84. A fourth GT2 NSX was entered by Nakajima Racing with number 85, but failed to pre-qualify. Car 46 finished but was not classified for failing to complete 70% of the distance of the race winner. Car 47 did not finish due to clutch and gearbox failure. Car 84, driven by Keiichi Tsuchiya, Akira Aida, and Kunimitsu Takahashi, finished 8th overall, winning the GT2 class after completing 275 laps. This NSX was featured in the original Gran Turismo, with the GT1 class car being featured in the Japanese version of the game instead. For the 1996 24 Hours of Le Mans, only the team Kunimitsu Honda NSX returned with the same drivers. It completed 305 laps to finish in the 16th position overall and third in the GT2 class. That's what's up, yo. J J GTC and Super GT. Okay, let's finish strong. There we go. JGTC and Super GT. In the 1996 season, prior to the formation of factory-backed Team Kunimitsu entered the first NSX in the series, based on the 1995 Le Mans GT2 car in specification. Without factory support, the car's best finish was 7th in the August Fuji Speedway race for the 1997 season. Honda officially entered the series with factory-supported NSX, which featured a chassis developed by Dome, based on the collaboration experience in JTCC series with Honda Accord and engines by Mugen. The car's debut race was at the second round of the series at Fuji Speedway, with the first pole position at the fifth round race at Mine Circuit. In 1998 season, the NSX obtained pole position at the seventh round of the series. The car also managed its first win at the Japan Special GT Cup in Fuji, and also won at the subsequent four remaining rounds of the series. However, the team suffered a minor setback when the number 18 Dome car was disqualified from the final race of the season. For 2000, the Phase 2 NSX GT machine was introduced, where the car's engine mounting was lowered and a Formula Nippon specification transmission was used. Although the transmission was proven to be fragile, Ryo Mishigami and his team Mugen X Dome Projects number 6 Castro NSX managed to get the first drivers and teams championship title for Honda. He had done so without scoring a single win. Following a facelift in 2002 to match the road car's facelift the previous year, the Phase 3 NSX GT featured changes to the car's V6 engine to prepare for the relaxed regulations for 2003, where the car's C32B engine was mounted longitudinally instead of transversely, as per the road car. So they turned the engine around on the race car for '03. Not bad. Similar to the setup used in modern Lamborghinis. The gearbox is located in the center tunnel under the cockpit and is connected to the rear differential by a drive shaft. Damn, kid, that's crazy, yo. Due to rule changes, Beginning in the 2003 season, the Super GT GT500 NSX was powered by a specifically modified version of the C32B engine V6. Using a stroke crankshaft from Total Racing, the naturally aspirated engine displays 3.5 liters and produced nearly 500 horsepower, 373 kilowatts, 507 PS. Beginning in 2004, Honda used a turbocharged C38 engine, outputting similar horsepower, but the engine cooling proved troublesome, and Honda reverted to naturally aspirated C32B the following year. For the newly renamed 2005 Super GT series, Honda created the NSX-R GT model to allow the Phase 4 NSX GT to allow the car to have extended overhangs, lip spoiler, and rear diffuser as effective aerodynamics measures. This allowed the car to obtain 10 pole positions and 5 wins in both 2005 and 2006. For the 2007 season, stepped floors was introduced to reduce aerodynamic ground effects. Even with these changes, the Phase 5 NSX GT won both the Team Championship and Drivers' Championship thanks to Autobox Racing Team Aguri ARTA with Ralph Furman and Daisuke Ito. The NSX continued to be used as the works Honda car in the GT500 class, even though it was no longer in production until it was replaced in 2010 with the HSV 010. The new 2014 regulations would render the HSV obsolete. Honda's 2014 spec GT500 car was to be based on the concept version of the new NSX, followed with a Group GT3 version from 2017 onwards. The NSX GT was used in the series between 1997 and 2009. It was one of the most successful cars to race in the series. It won 36 races, 45 pole positions, 3 teams and 2 drivers' championships, and finished runner up in the drivers' championship 6 times when it didn't win. It also won the Suzuka 1000 kilometers 4 times in 1999, 2000, 2003, and 2004. It is the only Japanese car in the series to score pole position and fastest lap in every race of the season, holds the record for the most consecutive wins at 6, and is the first car to win the championship prior to the final race. A GT300 specification NSX won the GT300 class titles in 2004 and finished second the following year. Honda NSX Super GT specifications. The championship machine specification in 2007 season. Under 2007 regulation, Phase 5 NSX GT was constructed as a new machine. Drivetrain, mid-engine rear-wheel drive, longitudinally front-to-back layout. Engine V6 C32B base, dual overhead cam, NA3, 1,494 cc's. Length 4,610 millimeters, 4,610. As same as NSX RGT 2005 with 2,000 millimeters. Wheelbase 2,530 millimeters. All same as all NSX. Transmission Hewland 6-speed sequential. Tires Bridgestone front 330 40 18T. Rear 330 45 R17. So on the race car, they actually put the tires backwards. Okay. The final specification in 2009 season. NSX GT for 2008 season was specifically allowed to use as the exception of 2009 regulation with receiving, performance adjustment, and handicap weight. Drivetrain MR special exception in 2009 regulation which requires FR in principle. Engine V6 C32B base dual overhead cam NA 3,396 cc's, downsize corresponding to 2009 regulation to make it equal to others. World Challenge. The NSX was entered in the SCCA World Challenge prior to the redesign in 2002. It won the championship in 1997 by driver Peter Cunningham. Pikes Peak International Hill Climb. In 2012, Pikes Peak International Hill Climb Love Fab Incorporated, led by Cody Loveland and Honda Performance Development (HPD), led by James Robinson, brought in their 1991 Acura NSX-based race cars into this field. Loveland's machine had monstrous spoilers and aerodynamic bodywork. The Robinsons machine had wide body, which is same as 1995 Le Mans race car, and his team continued to use the machine in 2013 and 2014 races with modifications. Safety car. Since the beginning of the NSX production, the car has been used as a safety car at the Suzuka circuit, even for the Japanese Grand Prix in its early years of production, and is still used at the circuit. The car is also used for the same role at Twin Ring Motegi, the other circuit owned by Honda. So we're going to go with the best of Suzuka and Twin Ring Motegi. And we're going to finish here with the NSX, right? We'll come back. Let's line everything back up in engineering for dimensions. We're going to return with HSV. Let's see where we are with HSV. And you know that this was the response to everything that happened. So I want to thank you guys for your time. We are logging off. Let me log off to my students here. Thank you guys for tuning in for today. We'll see you guys in the next one. God bless all of you guys. I am very proud of every single one of you. God bless. Okay, so now closing that off. That's going to be for later. Give me one quick second. This we don't need. This I am going to need. Okay, perfect. Okay, so basically, we will continue with the HSV, and I think we're going to add some new challenges such as the Lotus Esprit and the Corvette C5. As far as anything else, we'll check in the next class. See you on the next one. Radar Plex Systems inside, baby.